Hello dear students, in today's class we'll see one more kind of examples. So this examples also comes under eliminating the function only, but little bit a different way. Formation of PDE from phi of u comma v is equal to 0, where u and v are functions of x, y, z, but this z is being a function of x and y only. Okay, u and v are function of x, y, but this z is a function of what here? X, y here. Steps to solve such kind of examples. So they will give a function of two variables, that u and v, and we know that this u and v both are functions of what here? X and y. So given function of any variable, whatever they will give, you consider as equation number 1. Then differentiate equation 1 partially with respect to x and y by using a chain rule. So how to write a chain rule? Just see here. So we have to differentiate phi with respect to u, means phi of function u. Okay, first you have to apply phi, then with respect to u both. Then we need to apply u with respect to x. So this phi, dou phi by dou u, and this dou u with respect to x, with respect for u, and similarly dou phi by dou v and dou v by dou x. This is a chain rule of, because phi is a function of uv, and but uv is a function of what here? X and y. What happens here? Phi is a function of uv, but uv is a function of what here? Xy. So we need to follow this rule. So first phi you differentiate partially with respect to u, then this u you differentiate partially with respect to x. So first phi partially with respect to u, then this u, that is dou u by dou x with respect to x. So one chain is completed, plus dou phi by dou v into dou v by dou x. So with respect to x, give equation number 2. Similarly, dou phi by dou u into dou u by dou y, with respect to y we need to do, plus dou phi by dou v into dou v by dou y. We'll get equation 2 and 3. This is just explanation. We have to use the result directly in the problems. Now, transforming the second term. So this is the second term of equation 2, and this is the second term of your equation 3. We have transforming, we have to shift this term to the right hand side. So what happens? So dou phi by dou u into dou u by dou x will be on the left hand side. If you shift this, it will become what here? Minus times dou phi by dou v into dou v by dou x. Similarly, from equation 3, so dou phi by dou u into dou u by dou y keep on the left hand side, equal to, shift this one to the right hand side, dou phi by dou minus times dou phi by dou v into dou v by dou y. So got equation 4 and 5. So this equation 4 and 5 you have to divide. So left hand side divided by left hand side, right hand side divided by right hand side. So if you divide, so what happens here? This dou phi by dou u and dou phi by dou u get cancelled, and this minus cancels. Dou phi by dou v cancels. What left? Dou u by dou x upon dou u by dou y left on the left hand side, and dou v by dou x upon dou v by dou y left on the right hand side. We will write this one as dou u by dou x upon dou u by dou y is equal to dou v by dou x upon dou v by dou y. You remember this result number 6. So while solving the examples, we'll use this result directly maximum, and we can complete the examples now. So based on this, we'll see the examples, how it work out.